Hello, everybody. You should be able to hear me. If you can, just type something in the chat like GM or we can hear you or whatever, and then we can start. We're gonna wait for a couple of minutes, of course, for everyone to join, like you used to, and then we can start with today's workshop. Just type please in the YouTube chat if you can hear me well. Perfect. Perfect. Thank you. Sorry about my voice, by the way. Kinda lost it during this couple of days. But I hope that won't be an interruption for you to follow along. So as I said, perfect. Thank you, guys. As I said, we are gonna wait for a couple of more minutes for everyone to join. And then we are gonna start with today's workshop, which is building the SmartCon Web3 Raffle. So we are gonna try to recreate various types of raffles that were created for this year's SmartCon. So we are gonna use VRF for that, and we are gonna try to automate them using Chainlink automation. We are gonna use hard for this. So if you want to follow along, we have plenty of time. We have 3 hours allocated for this workshop, although I think we're gonna finish a bit earlier because I don't think we need 3 hours. But still, like, we have a lot of time for questions, for code along, for debugging, and other stuff. So as I said, we are gonna use Hardhat for this with TypeScript. So make sure you have at least Node installed on your machine. If you don't, you'll have couple of minutes now to do that. If you want to code along, but I assume all of you already have used not Node but Hardhat Foundry and other awesome tools already. We are gonna try to write some unit tests, and also like some test scenarios, like an integration test. You'll see what's that. And also we'll try to deploy everything to a testnet and see the whole flow. Although again, I'm sure you're already quite familiar with that. Okay, I think we can slowly start with today's workshop. So once again, we have 3 hours, although I think hour and a half, maximum 2 will be enough. So we're going to try to recreate SmartCon Web3 raffles. So there will be 2 raffles with slight difference. I'll walk you through all of them today. Okay, my name is Andrei Rakic. Maybe you already knew me. I'm one of the developer advocates for Chainlink Protocol Chainlink Collabs. You can see my Twitter handle listed over there and my Lens handle as well. So Andrei_dev for Twitter and Andrei.lens for Lens. So you can follow me there, and then you can ping me if you have any questions after the Q&A session, any other concerns. I will probably post my slides, my code, and everything on Twitter, so you don't need to search it. It will be on top of my profile, and so on and so forth. Okay, we can start. So today's agenda, pretty simple. We're going to try to create static raffle, and we're going to try to create dynamic raffle. So what's the difference? Okay, with static raffle, which was kind of the idea with Big Mac raffle, was that we already had a static number of participants, and everyone were eligible to participate in the raffle. So we have our participants prior to creating a contract. We're going to put all of them into the contract and just draw the raffle, which is cool. And the more complex one will be dynamic raffle, where again, you have the list of participants, but the thing is that they're only eligible to participate. So with dynamic raffle, the idea is that someone will go to, so idea in SmartCon was to come to our booth or scan a QR code or whatever, and then by scanning the QR code, they will actually enter the raffle. The thing is with dynamic raffle that you'll probably have less participants to draw. but you need to validate the ones who are not actually in that prior group of eligible participants. So you'll need to create the most gas efficient ways to create a Merkle tree with all of the eligible participants, and then they need to manually enter the raffle to call the function, but you need to validate that they are in the tree prior to let them enter the raffle. You will see how everything works, but before that, one more thing. If you have any feedback about this workshop or the previous one or the future ones, just scan the QR code, provide us your honest feedback so we can make these workshops even better, because they are for you actually. So to make you a better Web3 developers. So any feedback about this workshop or the previous ones or the future ones, just scan the QR code, fill the short type form, and that's it. Okay, so I think we can stop sharing this screen for the moment, and I can open my terminal so we can create actually a new Hardhat project. Okay, so I'll need to present my screen now once again. Let's see. Okay, you should be able to see my integrated terminal. If it's too small, please let me know. Otherwise, we can continue. So clear to start with a fresh instance. Okay, so first of all, we're gonna create a new folder. And we can call it, let's say, Raffle Workshop. I'm gonna cd to Raffle Workshop. And then we can just create a new Hardhat project called npx Hardhat init. We're gonna select TypeScript project, because once again, you can use JavaScript or TypeScript, whatever your preference is. My personal preference is to use TypeScript because it's statically typed language, which can help me to avoid some type or spell check whatever errors while I'm writing my tests and my front end in TypeScript as well. So we're gonna select this folder for the root. We're gonna add gitignore file, of course, and we are gonna install Hardhat toolbox. So if you used Hardhat previously, and maybe you noticed or haven't noticed, but Hardhat recently upgraded to Hardhat-toolbox package. So Hardhat ethers, Hardhat Waffle, or so Hardhat Waffle is basically deprecated, but Hardhat ethers, Hardhat type chain, Hardhat coverage, and all Hardhat guest report, and all other commonly used packages are now wrapped into one single package, which is Hardhat-toolbox, which is currently installed. But basically, if you use node version above 7, npm version above 7, sorry, then you're good to go. If not, you'll need to install some additional packages as well. For Yarn, that applies as well. You'll have everything in the README file or their main documentation, but it's pretty simple to start. So I'll just check my node version, my npm version. You see that I'm at 8, so I'm good to go. And then I'll just open a Visual Studio Code from this folder, sorry. So I'm using Visual Studio Code as my IDE. You can use whatever you want. You can write it on a piece of paper if you want, whatever your preference is. But the thing is that you will now need to open your IDE from this folder. As I said, I'm using Visual Studio Code, and if you're using Visual Studio Code, there's this handy shortcut code, and dot is just for this folder. So it's gonna open Visual Studio Code inside this folder, and I will now try to share my Visual Studio Code screen with you guys, and then we can start with the actual coding. Once again, get started. Okay. You should be able to see my Visual Studio Code get started page. I'm gonna zoom it a bit so it's easier for you to follow. Okay, so when we created a new Hardhat project, there are several things to notice here. First one is a contracts folder. So inside the contracts folder, your all Solidity file will go. you already have this log.sol, which is like a default one file. Inside the scripts will be all of the scripts you're going to write in TypeScript. So the basic and the default one is this deploy script, which is a script used for deployment of this log.sol contract. We're going to adjust the script, of course. I'm going to hide this just, okay. And finally, there's a folder for tests. So log.ts, again, all the tests files will go inside the test folder. And really important one is actually hardhat config. So all of the hardhat config will go here. At the moment, we only have like a Solidity version set up to the latest one and imported hardhat-toolbox, which again is a new package, which kind of wraps all of the common ones that are used inside or were used inside Hardhat prior to this hardhat-toolbox. Okay, so before we start, I have one more thing to show you, and this is the Hardhat extension. Just type Solidity, find this one. This extension is basically extension for Hardhat for Visual Studio Code. If you're using Visual Studio Code, I highly recommend you to use that, because if I go to my contracts, for example, and then I can just set that this is a Solidity file, you can see the really nice linting, then like formatting. You see like this, format. Also, if I type something wrong, again, error messages, all of that stuff. So I think it's pretty handy, and it's gonna speed up us a lot. Okay, let's start with the development. So first of all, we're gonna create a new file, called static raffle.sol. So as I said, we are gonna start with a static raffle. The idea with this raffle is we have all of the participants. Let's say that all of the SmartCon ticket holders are eligible. We only know hashes of their ticket confirmation numbers. This is for security reasons. That's why we as developers don't know actually who they are, but we know that the proof that they bought the tickets is the ticket confirmation number. And we are actually going to know hashes. So we're going to have a list of hashes. That's the info, all of the info that we are going to get from authorities, and that's it. We need to run a raffle with 7 winners. That's it. So that's basically how the Big Mac raffle was created. So everyone who bought a ticket at certain time frame were eligible. We, as a devs, only know this info, and we needed to create raffle, like a static raffle, to put all of these hashes into the contract and then just run a raffle. So it looks like pretty simple, but we will see how it actually you can make this. So you can start with maybe I can just Command Z. But what I did is basically I typed use tab. So this is also coming from a plugin. However, I can. It's not a dumb question. So however, I can download all the source code that you're working on now. It's not live yet on the GitHub. We're currently creating the project, so you can follow us, code along, or if you can just watch, and then I'll post on my Twitter the source for the GitHub link to the source code after this workshop. So it's not on GitHub yet. We are currently writing it at the moment. So we'll see how everything's gonna go well. Okay, so Pragma, Solidity, we can use 0.8.0, and then we will need to add SPT or I can put the comments here and then just SPTX license identifier MIT. And then we can name our contract as static raffle. And that's pretty much it. You're welcome, Lucas. Okay, so let's start with the actual coding now. What we want to do now is actually to install some packages. So we will need Chainlink contracts for sure for VRF stuff, and also we'll probably need OpenZeppelin. So we can start with the VRF stuff first. So to use VRF, you need two imports. So the first one is gonna be to import VRF coordinator v2 interface from, and this is gonna be much easier if I first install everything. So I'm gonna open my integrated terminal. Sorry guys for this. So we wanna install npm install save dev as a dev dependency, Chainlink contracts. Okay, so this is the command we need to type in now to install Chainlink contracts. So once again, npm install. This is just to be installed as a dev dependency. Add Chainlink /contracts. Hit enter. So I'm currently installing this command, and Andre, what's your Twitter handle? It's Andre_dev. This one. Okay. So I'm gonna put this down actually, or I can actually, yeah, if you want to follow along, I can, yeah, this is the command you need to run. You're welcome. So you'll install this, and then we can, yeah, let's put it like this. So from Chainlink contracts src v 0.8 interfaces VRF coordinator v2 interface.si. Okay, let's now to try to compile this to see if were there any typos. npx archive compile. I'm gonna hide this for a moment. Okay, looks like we did our work correctly. So for you, first import is this one. So you can grab it from the chat, or I can put it here. So this is the first import you want. And then let's go with the second one. So the second one is to import actually VRF consumer base v2. So the thing is that all of this stuff you have at the official docs. It's copy paste stuff, pretty easy, but still we're gonna type it here. So and import VRF consumer base v2 from, again, Chainlink contracts src. Again, version is 0.8. Why? Because we are using that version of Solidity. And VRF consumer base v2.sol. I think this is the correct import. Let me quickly check. Looks like it is. Again, we are gonna validate this by, first I'm gonna try to actually, no, just by typing again npx hardhat compile. Looks like this is correct as well. So I'm gonna copy paste this for you, so you can import that in your contracts as well. And then we're going to start with, we're going to continue with the development. So we need to, if you follow along the official docs, we need to now import consumer base V2 contract. And there's an error already because we should import some abstract, we should import some methods from this contract. I'm going to hide this so you can follow along. Interface. Have you installed Chainlink contracts using this command? If not, first you need to install Chainlink contracts using this command and then import using this one, okay? If you have any issues, please let me know in the chat. Okay, so static raffle, we need to import some, so we need to yeah, let's do it like this. Okay, so first of all, if you follow along the official docs, yes, you have imported file import callbacks supported. If you have installed it, go to package.json file. I'll quickly do that now. If you go to package.json now, you should be able to see this. If you cannot see this, try to manually enter stuff like this and also run npm install and also check for maybe typos, but I think we did the correct stuff here. But please let me know if there are any issues. Okay, so first of all, if we follow the official documentation, we'll have some stuff like this. So VRF coordinator v2 interface is internal variable, can be immutable variable actually to save gas because we are not gonna change it. Okay, this is okay. Then maybe there is a typo. Okay, give me a sec. Contracts, SRC, interfaces. You should be able to be good. Save an error with imports. Give me a sec, guys. Can you try, Aragon, can you please tell us what did you do? What? Okay. Try close the VS Code, Sarah, and start again. Sorry, maybe that's the issue. Thank you, man, for your support. Okay. Immutable, and then the name of the variable can be VRF coordinator. I put this I letter here to mark the variables that are immutable. So I'm using I something for immutable variables and also S for storage vars to be aware of the gas costs and everything. To be aware that I'm using storage variable or immutable variables because of the gas cost, because storage is expensive, immutable is not. Okay, so then let's speed us up a bit. Internal immutable I subscription ID. Hope there's no typos. Then bytes 32 internal immutable key hash. Then we want to have unsigned integer 32, which is again internal variable, which is immutable variable, and it's going to be call back gas limit, and I will say UN16 internal immutable I request confirmations. All of the stuff from the actually official documentation, all of the stuff you need to work with the VRF raffles, or with the VRF, sorry, with the VRF. Okay, and the final thing is that we at the moment need UN32 internal, which is going to be a state variable, which we can change, but that's basically numbered. So this is a number of random values we want. And it's going to be 7, but if we want to be more flexible, then we can make it a storage variable, not an immutable or constant. And then we can create a function to update that storage variable. Pretty simple. Okay. That's pretty much it. Now we need to create a constructor. So constructor, this is a function that are going to be executed, upon a creation of a contract, and only that. So we need to add VRF consumer base v2 here, and to pass VRF coordinator. Okay, so because we haven't instanced these values, we can put all of them into the constructor. So UN64 can be subscription ID, and just delete this. Then address can be a VRF coordinator. Then what we have? Base32 key hash. We have UN32, which is a callback gas limit, and we have UN16 request confirmations. Okay, that's it. We need to pass this address here and open curly brackets to instance all of our immutable variables. So subscription ID will be subscription ID. VRF coordinator will be VRF coordinator. Callback gas limit is going to be callback gas limit, and request confirmation will be request confirmations. One thing we yeah, so this is not an address, this is actually this thing, VRF coordinator v2 interface of this address. Okay, so this is the syntax. And also we do have this number of words. So what we can do here, although we know it's 7 for the sake of flexibility, we can pass it as well through the constructor like this. This is UN32 number of words. And that's it. We have our constructor. I hope this is clear so far. Sorry, guys. Let's put this here. So this is just the standard VRF stuff. I assume you already know that. Let's now just add that request and fulfill random words function and then functions like bodies of that, and then we can start with the actual logic for the raffle. Okay, so let's see. Okay, so move on up. So function request random words. It's gonna be internal. So internal means that only your smart contract and the smart contracts derived from them can call it. It's not accessible to outside world, let's say. So for other wallets to call it. And that's gonna be it. So we are gonna have something like this. So this is request ID. You already know that, but let's say EA VRF coordinator request random words. We need to pass key hash, then subscription ID, then request confirmations, and callback limit, callback guess limit, and number of words at the end. I'm gonna save this. Okay, so I hope you can see this now. I'm gonna stop it for a moment. So this is a request to the VRF. On Chainlink VRF, okay. And yeah, that's it. Now we should add something like this. So for fill, I have a typo, fill random words. It has uint256, which is a request ID, should be the same value of this one, okay? And also the actual random values. So once again, memory, random words, okay? Those are all of the random values that we are gonna get as a callback. And that's it. This function is internal. This function is virtual, and it's override. Okay, so what does it mean? Basically, this function comes from this contract, and because we are inheriting, we need to implement that function, and that's why this override keyword comes from. Okay, so we at the moment does not have anything to do here because this is just catching random values from provided by Chainlink VRF as a callback. Okay, so here we are gonna decide winners, but we need first to create to have a logic for that as well. And because of, I'm gonna quickly comment this function to get rid of those errors, and then we are gonna uncomment it pretty soon. Do you have any questions so far? I assume not, because this is just a standard VRF stuff, but still, let me ask. If you have questions, just type it in the chat. Okay, so we want now, because we have actually, we have, as I said, a list of hashes of ticket confirmation numbers. So this is an array. We would love to have something like this. To have an array of all participants. To have an array of winners. And the thing is that if we would like to remove winner from participants array and add it to winners array. That's it. So we need to create logic for this. Okay, so to do this, OpenZeppelin has a really handy contract. So I'm now gonna install OpenZeppelin. Okay, so npm, let's do clear so you can hear. Npm install save dev OpenZeppelin contracts. Okay, and hit enter. So this is the command. let me quickly paste it here. So we need to install OpenZeppelin contracts. Okay. And now what we want to do is actually import that handy contract called enumerable set. So import enumerable set. Let me quickly check for typos. And this is coming from OpenZeppelin contracts. This is from utils structs enumerable set.sol. Okay. I'm gonna just quickly comment this to see if everything's okay. RFF compile. Should be, but yeah. Okay, we don't have typos. Sorry about that. So you need to import this now. Okay, and then we're good to go. I'm gonna hide this one more time. Yes, so what we want to do now is basically to use this. So how we can use this contract? By typing using enumerable set for enumerable set dot bytes 32 set. So here you can use address set, uint256 set, all that stuff. Our array is going to consist of bytes 32 basically bytes 32 types, because bytes 32 is a type, data type for Kachak hashes. So when you have a hash, that's bytes 32. As I said, we only have hashes of their ticket confirmation numbers. That's the only info we have because of the privacy reasons, and that's why we need to have a bytes 32 array. Why not the regular array? Because this one is pretty handy for the deletion, basically if we want to delete element from this set, is just to call a delete function. Otherwise, we will need to code our own delete function by putting the current element you want to delete to the last value, and then the last one here, and then just to do a pop, which is too much work. We can just reuse OpenZeppelin's contracts. Okay, now that we have this bytes 32 array, let's now create this type. Sorry, let's now create the actual arrays. So the array is going to be an enumerable set dot bytes 32 set internal participants. So this is participants array, and then the same thing for winners array. 32 set internals as winners. So this is winners array. Okay, so because we know our participants before the actual creation of a contract, we have that array, we can just paste it here as a constructor parameter, basically. So because it's a bytes, let's do it here actually. So it's bytes 32 array memory keyword to say yes, participants. Okay. So it's gonna be bytes 32, and what we're gonna do here is to loop through participants array and allocate as participants. Okay, so this is actually anti-pattern, and this is a really costly operation. So that's why we want to loop only here. So to save some gas on looping, let's do first this. So go to Harkit config file, actually. Go to the Solidity. I'm gonna just check the syntax one more time. Yeah, so go to the Solidity and do something like this. So delete this and open an object, okay? So version is gonna be 0. What we had, 17, or we can do 7 actually, because 7 is the stable version. So without any known bugs at the moment. So let's do 7. And also we are gonna do settings. And now inside the settings, we want to turn optimizer. So optimizer like this, and then enabled to true, and runs default one, okay? So this is gonna actually optimize our code to save us for an extra costly opcodes. So this is basically the same if you write some part of your code in your language, but you also open the assembly curly brackets. There's a high possibility that the optimizer will do exactly the same for you. So that's why we turn on the optimizer, and also we'll try to save some gas here as well. How? If I go back here, give me a second. Okay, so we can first cache the length of the array into the memory variable. So uint length is equal participants, okay, dot length. Why? Because if we query the length variable from the participants array inside the for loop, that's now is the same because it's in memory. But imagine that you have a storage variable. That's an extra sload call. By caching it here, so it doesn't matter because it's memory. But for general usage, by caching it here, you're saving tons of gas actually, because each sload is 22K at the first, and then decrease at the usage to 100 and 100 because of the warm and cold storage. But actually mload, which is reading from memory, is only 3 gas always. So 3 is less than 122K 2200 for sure. So this is a good gas savings tip. Okay, so now more tips. So uint e equals 0, and then less than length, less than this variable, and that's it. So we are now do something like this. So as participants, add participants of I like this, and also to save some gas, we're gonna open unchecked block, and do something like this, plus I. Okay, why unchecked? Because we are gonna disable overflow and underflow checks. Why? Because we are sure that it's not gonna overflow, because we know the value of length before the creation of a smart contract. Because again, it's a static raffle. We already know what our participants are, what was the value so far, or their hashes of their tickets, let's say, and that's it. So this is the only addition you need to add to the constructor, and that's pretty much it. Any questions? Maybe again, if you have it, just type into the chat. If not, we can continue. I hope the pace is fine so you can code along. If I'm too fast, please let me know, and I can slow a bit down slow things a bit down as well. Okay, so how are we gonna draw raffles? So we do have this request random words, and that's the only thing that we actually need. Sorry. So we are gonna request random values. We're gonna request 7 random words, 7 random values. We're gonna provide it here, and that's it. Inside this fulfill random words is the actual logic for drawing winner, remove winner from a participants array, and add it to the winners array. That's it. Okay. So, okay, let's run the raffle function. Run a raffle. External to say some gas costs, and that's it. We need to just now call request random words function, and that's it. We ran our raffle. There's a couple of problems here. We don't want anyone to be able to run a raffle, right? Kind of we want that. And we want this raffle to be run only once, right? So we can solve how we can actually solve these two problems. Does anyone have any ideas? Write in the chat, please. So we don't want anyone to be able to run a raffle, and we want this raffle to be run only once. Because at the moment, anyone can call run raffle function, which means that some bot can outperform us and run the raffle, which is not good. Okay, so for the first one, we actually need to add that famous only owner modifier. Exactly, only owner modifier, exactly. Yeah, we need to apply a modifier for the first one, and we are gonna see what we are gonna do for the second one. It's probably be a modifier as well. Okay, so only owner. This is of course red because we haven't imported from OpenZeppelin. So let me see off the top of my head if I can remember where the ownable is. Ownable from, or we're gonna just Google it. That's fine as well. OpenZeppelin contracts. It's gonna be. It's easier if I Google it. So yes, let's Google this really quickly. OpenZeppelin ownable. Okay. Yeah, it's access. Yeah, access ownable .sol. Okay. So this is ownable, and we need to put ownable here, and the error should go away, and it is. So this is the first stuff. So we applied only owner. The second one is we can also apply modifiers. So we can create our own, for example, only once modifier. So how you're gonna create a modifier in Solidity? That's pretty easy actually. So we can put here, so modifier only once, and we need to have some kind of flag. So we can create a Boolean value, let's say here. So Boolean variable, sorry, can be internal as well, and can be is raffle started, for example. So bool vars are false by default. Okay, so this means that this variable is now false. So I don't need to insert it here inside the constructor. It's false. So we want to check something like this. If is raffle started, then revert with an error we need to create. An error can be something like this. So error raffle can be run only once. Okay. We want to revert with raffle can be run only once. And the thing is that with modifiers, you always need to add this underscore value. Underscore means that it's gonna, if this reverts, it's gonna start with the execution. We're gonna stop with the execution, sorry. Did I put only once modifier here? I did. And we're almost done. So we need to just, because, yeah, we need to set our is raffle started flag to true now. So if you want to rerun the raffle once again, that's not going to be possible. Yeah, optimizer saves gas a lot. So that's why we turn on optimizer. Okay. So this is our run raffle function, pretty standard. What we can do is just add some nut spec as well, but we'll see if we have time for that. So this is run raffle. This is request random words. What we can do is actually, because we are running raffle here by requesting random words, we can put some event here as well. So event can be put like here. So event can be raffle started, for example. And yeah, we can put actually here request ID as well. So we know for which request to look on Etherscan. And where am I? Yeah, I just need to emit raffle started and put this request ID here. That's it. We can also add, sorry for confusion, indexed keyword here. So with indexed, it's gonna be inside the Bloom filter, which means it's easier to search. So it's more searchable from block explorers and also your front ends. So we have raffle started, and we now need to put our logic for declaring winners here. So we have now a storage array with all of the participants. The storage array with winners is currently empty. We want to grab all of these values from random words. There should be seven random values, but a really huge one. We want to scale them. So if we have like 50 participants, this random number will need to be inside the range of 1 and 50 or 0 and 50, whatever your logic is. So to get random values from a range, you need to know actually the length of your array, and we know that luckily. So let's cache it one more time. uint256 length is equals to s number of words. Why? Because this is a storage variable. This is a memory variable. It's cheaper. Code is not cleaner. There is more code, but this is cheaper. Okay. So we need to run our loop once again. Uint e equals 0, and then I is less than length, and then inside this loop we are going to have something like this. So bytes. This is byte 32 is a hash value. So basically, this raffle winner is gonna be s participants at. So this contract from Etherscan has this really handy function called at, where you can grab a value inside the array at that particular index. So at index, and now it's random words of I, then modulo. Once again, we're gonna have something like this. Give me a sec. Yeah, let's do something like this. So uint256 participants length is equals s participants dot length. So we're gonna once again. No, we cannot do that. Sorry. Wanted to save some gas, but we actually cannot do that. Sorry, we are gonna do it like this. Why? Because we are gonna delete some values from the participants by one, and that's why we don't know actually the actual number. It's not going to be a static number, sorry, so that's not possible. But so this is a raffle winner. Now we need to remove, or first add to winners array, and then remove from participants array. Okay, how to do that? Easy. Okay, so we have winners, add. This is an add function. We're gonna add raffle winner here, and also as participants dot remove raffle winner there, and that's it. Almost. We just need to do uncheck block to increase our loop, and that's it. So final thing is that we will probably need to emit some event there, or actually two events. Actually, we want to emit for every winner, so that's going to be raffle winner and raffle winner, and we want to emit an event raffle ended. Okay, with request ID one more time. That's fine. Okay, so let's declare those two events. So raffle winner, okay, event raffle winner. It's gonna be as I by 32 value, I think, raffle winner, and then we want to have a raffle ended, which is gonna be uint256 request ID, and we can also put indexed values indexed. Okay. Give me a sec. VRF coordinator. Did we miss something here? Oh yeah, we missed key hash. Oh yeah, sorry guys, that's the problem. So key hash equals key hash. Okay. Okay, now it's better. We don't have that nasty error. Okay, so we declared two more events. Okay, raffle winner and raffle ended. And if I scroll down a bit, we're gonna emit raffle winner and raffle ended here. So this is it basically. You have random values inside the range. You grab raffle winner, then add it to the winners array and remove for participants array, and that's it. Final thing that we need to add is basically a view function to see all of the winners. So how to do that? We can put it maybe here. Function get winners is gonna be external as well, but view, okay, and it needs to returns array of bytes 32 values. So bytes 32 array memory. Why did I put it just here? Because I want to have all of the external functions. So first of all, public functions, then external functions, then internal ones, then private functions. Okay, so I don't want to mix them, so it's easier to read your contract. So these two functions are actually callable from wallets. These two are not. So that's why I put it here. And this is going to be a pretty simple function. So return as winners dot values. This is also really handy built-in functionality from OpenZeppelin's enumerable set, and that's it. So we have winners, we have everything. Do you have any questions at the moment now? Because there's like a lot of code. Should be clear to you, but still. If you have any questions, please post them in the chat. I'm going to try to compile this contract by typing npx hardhat compile. Okay, because we changed, we can just delete this lock. And let's try one more time. Because we changed the version of Solidity to 0.7 and the lock was to 0.9, was set to 0.8.9. Okay, so this works. We have a smart contract which is stable. Now the hard part is actually to write some tests, because without the tests, we're not actually sure that this is working properly. So let's go to the test folder and let's create a raffle with like a 7 participants scenario. So how to do that? I'm gonna delete this file as well because we don't need it. And yeah, let's name it something like raffle with 7 winners dot scenario dot yes. Okay. Okay, so let's first start with, I hope you can see this. If you're not, please let me know. So we're gonna start with a describe block, and we're gonna type something like, or it's better, static raffle test scenario with 7 winners. Do something like async function and open curly brackets here. So the first thing, if you follow along the intro to Hardhat workshop, is that we need actually to create fixtures, to create a function to deploy smart contract and then to load it as a fixture to save us time and resources. So async function deploy static raffle fixture. Can you follow along so far? And okay, we have that function and we want to have something like this. So we need to grab deployer from ethers get signers like this. So ethers is imported from Hardhat and get signers is just to get, let's say, get some signer with address array with some values of signers with address. This is basically mock wallets. Let's treat it like that. So mock wallets, from that array, we only grab the first one and we name it deployer because our code will be much cleaner that way. And now we are going to actually try to deploy that our raffle. So how to do that? So const is going to be static raffle factory await, again, ethers get contract factory, and it's going to be static raffle. Okay. And then what we want to do here is static raffle equals, or we can add a type actually. Yeah, we do have it. So this is automatically generated from type chain. So don't worry about that. Type chain is basically a handy tool which generates TypeScript types out of your Solidity code, and it helps us a lot while writing these tests. What we want to do now is await static raffle factory deploy, and we have a bunch of stuff here. So we need participants array, subscription ID, VRF coordinator, callback guest limit, request confirmation, number words, and that's it. So you can also hardcode all of this stuff inside your smart contract, and that's the actual implementation of the official Chainlink docs. But what we can do here is that we can be more, let's say, scalable, because if you want to deploy to multiple different testnets or mainnets, those values are going to change. So you can pass all of them through your deployment script, and that's why we put all of them inside the constructor. So we're gonna put all of those values here, and yeah, just run our tests. So I'm not gonna share the official docs. I'm not gonna copy paste from there. You can do that, but I think it's gonna be better for you. You can follow along here. So we need actually one more thing. For participants, let's create mock participants first. mock participants. This is gonna be bytes like array. And I should be able to grab some mock hashes from somewhere. Okay, I have something, but how you can do that? So let me quickly check on the Google one more time. Mock catchup 256 hashes. Oh yeah, let's do it like this. Sorry guys, we can do something like this. If I'm gonna stop presenting for a moment, then we can go to online website. Okay, so what I did now is, sorry, share screen. Is there a Chrome tab maybe? Oh, there it is. Perfect. So I went to Catchak 256 online, and I will just input something, and then we'll always have some values. Okay, so let's do something like this. So a yeah. So let's do it like this. Yeah, I'll put it here as a comment, and then we're gonna go back. So let's do something like A, B, C. This is just done ticket confirmation numbers. Sorry about that. C, D, E, F, G, okay, we 1, 2, 3, 4, 5. We have 7 already. Let's do 10. G, H, I, and then J. So you can save all of this stuff. This is just the mock values for testing, not the actual ticket confirmation numbers. I'm gonna stop sharing this. I'm gonna go back to our Visual Studio Code. This one, okay, you should be able to see this. So I just copy pasted all of these dump Catchak values here, and I'm gonna create bytes 32 values out of this. So to do that, you only need to add something like this. So 0x and then the actual value of hash. Okay. So let's speed us up a bit. 0x. Okay. 0x. Okay. Oh, sorry. This is the format required from Solidity, unfortunately. So nothing we can do about it. X and save it. And Oh, we need to import bytes like. Bytes likes come from ethers as well. But the correct import is, give me a second, is something like this. So import bytes like from ethers lib utils. Okay, so this should work. So bytes likes is basically a type that can be either a string or bytes. Can you paste? Yes, I can. So mock participants, not good. So I can just copy paste this inside your, I hope. Oh, maybe it broke. Sorry, guys, but you should be able to collect it. And bytes likes is from this. This is the input, okay? But you can just use whatever dump hashes you want. You can use like 3, 5, whatever. We're gonna create a raffle with 10 participants and 7 winners. This is our scenario. Although there were much more participants, obviously, in the actual raffle. And yeah, please let me know if you could not collect all of this info from the chat, because it looks like kind of broken, at least from my view. Okay, so go back to deploy. We need participants. So the first thing is mock participants. Then we need subscription ID. So subscription ID, basically when you create a VRF subscription, you need to save that number, and we're going to do that inside our deployment script. But here we want to mock this. So to be able to mock subscription ID, we need to deploy actually the mock VRF coordinator. So we're going to stop with this now. Go to contracts folder. Inside the contracts folder, create test folder. And inside the test folder, create mock VRF coordinator v2.sol. So if you're familiar with the Hardhead starter kit, you maybe notice that this contract is present there as well. So your VRF mock subscription is gonna look like this. Yeah, I'm gonna save it. So you just need to import VRF coordinator v2 mock from, or let's say rename this, sorry guys, to the actual. So it's VRF coordinator v2 mock. Okay, so this is the actual contract. I'm gonna paste this to the chat as well. So this is the whole code for your, oh, it's not visible, never mind. This is the whole code. Sorry, it's kind of like broken, doesn't add white spaces, but this is the whole code for the mock VRF coordinator. We're going to use this mock VRF coordinator to create our mock subscription, to get the subscription ID from there, and then to also use it to simulate a callback from Chainlink VRF locally inside our unit test scenario to see does our logic for raffles work. Okay, let's go back to the test file. I'm gonna slow this a bit so you can follow along. You can paste everything, but yeah, again, const, it's gonna be now VRF coordinator factory, which is gonna be, again, await ethers, get contract factory, and there is no contract factory. Why? Because we need to compile this one more time. Sorry, Hardhead compile. Okay, now we should be able to see, or maybe not, ethers, get contract factory, VRF coordinator v2 mock. Here it is. So we're looking for that contract, and we just need to deploy it now. So this is going to be our mock VRF coordinator. It's going to be a type of VRF, coordinator mock. This is also from typechain, and it's going to be await VRF coordinator factory deploy. That's it. Actually, it's not it. We need base fee and gas price link. So we can put it as a constant. So constant base fee is actually 1 with how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1 with 18 zeros. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And so this is one link. And gas price link is gonna be it's gonna be 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why? Because this is 2, 3, 4, 5, 6, 7, 8, 9 a link per gas, and all of these configs you can read. So we can add some comment here, maybe something like this. So dev also, or maybe this is even better. Dev read more at https docs.chain.link, and what's the actual name? It's docs Chainlink VRF. So you can basically find all of these values there. So we are just going to use it to deploy our mock coordinator and gas price link. That's it. So we have our mock VRF coordinator. No questions. That's always great. And let's now create subscription, shall we? So to create subscription, we're going to use something like this. Await mock VRF coordinator, create subscription. That's it. But the thing is that we need to return our request ID subscription, and it's actually because this is not a view function, which cannot do like const request. So we cannot do this instead of saying maybe so const request ID. So we cannot do that because this is not a function. This is not a view function. So we need to actually grab it from the actual event. So how to do that? We're going to create a transaction. So transaction is type of contract transaction. Transaction. I'm not sure why this is not automatically imported, but the import should be from here. Or maybe not. Give me a second to see the actual import. Oh, this is just from ethers. Okay. So import contract transaction from ethers. Okay. So this is contract transaction. And now, because we have a contract transaction, we need to wait for this transaction to happen and to put everything inside a TX receipt. So receipt, this is contract, the receipt. Let's say, is this possible? No. So contract receipt is also from Ether. So receipt. And contract receive, we can grab like emitted events, logs, all of that stuff. So because transaction is just a transaction that is that it's created to be passed to the mempool, and after transaction is included in the block, then we have like a receipt. So we basically see receipt on Interscan when we go to the when we search for transaction hash and we see all of this giant data. Transaction object is a bit different, so we need to wait TX to happen, and we can put one block confirmation because we're in a local hardhat environment. So we now need to look for events. We need to first check because tx receive.events, if there is no events, we just need to return from this because this is TypeScript type stuff. If you're in JavaScript, you don't need to do that, but this is just extra security to add it to our code. So construct a subscription ID. Subscription ID equals tx receipt events of 0 and topic is 1. So you can also just console log this and grab your subscription ID from there, but it's always going to be in the first event as a second topic. What we just need to do now is to do something like this, big number from, because this is a string. This is a string, we need to convert it to big number. So because we want to pass here up uint256. So participants, subscription ID now. What else? We need VRF coordinator. So this is the address of our VRF coordinator. We do have that. So this is mock VRF coordinator dot address. Sorry. So we do have that. The next thing is key hash. So key hash is something that we can grab from official docs. Grab from the docs. We are going to use the one for Goerli testnet. So you can grab it from the official docs, or I can just paste it here. Key hash is equal to, I'm now inside the docs. It's equal to this value. Okay, so you don't need to go to the docs. Here it is in the chat. Then call by gas limit. Let's first put key hash here. So key hash next is call by gas limit. Okay, so callback gas limit. I'll use the maximum value from Goerli testnet, which is 25 and then 5 zeros. 1, 2, 3, 4, 5. Okay. So if you want to follow along, I can easily copy paste this for you guys. Give me a sec. Oh, I lost it. Sorry. This is called by gas limit. For the request confirmations, let's do the default one is 3. Let's do 5. Request confirmations is 5, and then actual words will be 7. Why? Because we are looking for 7 winners. Okay. And then I'll just say what's okay. So this is called by gas limit, and then we have request confirmations, and then numwords, and that's it. So it looks like we're done with this stuff. Finally. Okay, so we have our static. Oh, let's move the cursor. So we have our static raffle deployed. We now need to add it as a consumer to our mock coordinator contract and to fund that subscription. Why? Because if you remember, that's the actual flow on the VRF subscription page. So when you go to vrf.chainlink, you need to create subscription, save request ID, then fund subscription, fund it with some amount of link, then deploy your contract, and then add your contract as a consumer. So that's what we're gonna do here. inside our text, we're going to mock this. So mock VRF coordinator, fund subscription. Subscription ID, we do have that. And let's do file link. So parse ether. Oh, I can, no. Parse ethers is coming from ethers, I think. Let's quickly check that. No, it's actually from utils. So here, parse ether from this. Okay, so you need to expand this import. Is that okay? And then parse ether 5. After we funded our subscription, we just need to add consumer, VRF coordinator, add consumer, and consumer. Okay, first subscription ID one more time. And a consumer is our static raffle. So static raffle dot address. And that's it, hopefully. So this is our fixture. We want to return from this fixture some stuff. So static raffle for sure, and we will see about the others. So we'll see what we need in our tests, basically. Okay, I'm gonna close this. And now let's create our test. So first we want to describe the block one more time. Then we want to say something like running raffle scenario, and it's going to be async function. Yeah, it should run raffle and determine whatever 7 winners only once. So this is our request. So we have async function. And yeah, so how to do that? So first of all, we need to load some pictures. So we need static raffle, await, load fixture, deploy static fixture, and fixture is because my tab is not working today. I'm not sure why. If you follow along intro to Hardhat workshop, you already know that fixtures are coming from this import. Yeah, okay, cool. I'm gonna paste it here to save you some time. So we have static raffle here. Okay. Let's continue with our test. So we need to have also a deployer because that's our owner. So we need deployer. We actually need mock VRF coordinator. Why? Because we want to simulate the callback from Raffle, and we will see, do we need something more? So if I open here, we need to return also deployer and mock VRF coordinator. So this is from fixture. I'm gonna close the fixture, and then let's see how our test is gonna look like. So first of all, we want to, we want to await static raffle connect with deployer, and then do something like, what's the name of the function? Sorry, run raffle. Yeah, run raffle. Okay. We have some errors. Property static raffle. Okay, we messed something here. Give me a sec. Oh, there's a possibility. Oh yeah, give me a, let's do like this. yeah, because fixture can be undefined, let's do something like this. So fixture, then return, and then we can do something like this. So, okay, this is fixture.plur. Kind of annoying, but sorry guys for that. And yeah, now we have our run raffle function. The thing is that we kind of want to have request ID from this function, because if you remember our static raffle, when we run our run raffle function, inside this request random words, we have this event raffle started with request ID. We want to get that request ID, and in order to mock the callback from VRF coordinator. So how to do that? Let's do a transaction one more time, which is a contract transaction, and let's do const tx receipt, which is receipt. Wait tx wait for one, and let's console log tx receipt, because I'm not sure where that event is. So let's try to run this clear npx hardhat test. Okay, so if we expand this a bit, we are looking for events emitted from this contract. So we have the first one, which is okay, and which is some general array, and here it is, raffle started. So we're looking for that event. It is the second one, and inside the topic should be inside the topics should be our request ID. Why? Because this event, sorry, is we have this indexed keyword. Okay, so whenever we have indexed keyword, this means that the variable will go inside the topic. So what we can do now is basically, if there is not tx received events, then just return. And if there is not tx received events of one, actually there's an argument as well. Yeah, there's an arg. So if there is no, let's do it with arguments, because not all of the events variables going to be in topics. So inside the arguments, you can see all of the event arguments. So we're going to do it like that. So if there is nothing inside arguments array, also return, because that's possibly undefined. No questions yet. Really cool. And now let's just console log this stuff. Console log args array. Okay, to see the actual event arguments. npx hardhat test. Okay. Do I have something more console logged? Oh, these are the arguments. Really cool. It looks like, oh no, for some reason it didn't. Oh yeah, I have this console log receipt. Sorry guys, I saw it's a mess. Let's do one more time. Just console log arguments. Oh, perfect. So request ID is at first position, which means it's 0. So our request ID is actually arguments of 0, because there's only one element here. And cool, we have our request ID. Put this down. Now, when we have a request ID, we run the raffle. We now want to mock the callback from Chainlink VRF. To do that, To do a mock, we have our mock VRF coordinator, which is fixtures. So we need to wait to show this. So this is fixture mock VRF coordinator. Then the actual function should be fulfill random words. Should give me, yeah, here it is, fulfill random words. So fulfill random words, accept request ID and the consumer. So request ID we grabbed. Consumer is our fixture.staticraffle.address. And that's it. So the thing is that now, because we have this fulfill random words and everything, we should be able to see the winners. So if I const winners, await fixture static raffle winner get winners, get winners. We should be able to see winners, but let's see winners. Okay. Clear npx hardhat. There it is. So there's something. Let's quickly check that. So 1, 2, 3, 4, 5, 6, 7. So we have 7 winners, which is cool. But this is a not actual test. So the test will be to assert some values. So how to do that? We need to assert. And first we need to import assert from Chai, I think. From Chai, okay. Also, again, standard stuff when working with hardhat. So we're importing assert from Chai. It's in the chat. So we want to assert that the length of the winners array is equal to not 7. Let's grab that value from fixtures. So it's gonna be numwords, okay, because this is cleaner. If we change our numwords, we can just put it here. So this is gonna be fixture dot numwords, and then we have something like, so invalid winners number. Let's say, so this error, this string is gonna be displayed as an error if this particular assertion failed. Okay. So one more time, npx hardhat test, and that's it. So this is it. We created a static raffle using Chainlink VRF, and we also wrote a test to simulate the actual execution of the raffle. So our logic inside this function, fulfill random functions, for selecting 7 winners works, which is awesome. So do you have any questions so far? This was basically Big Mac Raffle recreated, with some parts, of course, excluded. Okay, if you don't have any questions, which is awesome, that means that you follow along everything, then we can create now dynamic raffle. So, okay, dynamic raffle.sol. And we can just now reuse some code, of course, from our static raffle. But the idea is with dynamic raffle is to allow participants to enter the raffle by themselves. So we want to have now Merkle tree with eligible participants, and to allow them to enter manually. Okay, so how to do that? Let's start again with pragma solidity. .7. Okay. Let's add MIT. Fantastic. Contract dynamic raffle. So we'll need some imports from here. So VRF start, we can copy VRF stuff, we can copy that. Okay. Again, enumerable set, of course, ownable, of course. So all of the imports, just copy paste here. And for the Merkle tree, we will do something like this. So it's going to be Merkle proof from open Zeppelin contracts utils cryptography Merkle proof.sl. I hope this is the correct one. I'm gonna copy paste this to you in the chat as well. Will there be a GitHub repo for this lesson? Yes. So everything I'm coding right now, I'll post to GitHub after this workshop and post everything on Twitter, on my Twitter or Discord or whatever. Just follow our socials. And then you can just have a full source code for this lesson, of course. Okay, so this is the dynamic raffle. A bunch of stuff we're gonna reuse actually from the static one. So this is gonna be VRF consumer base V2. This is gonna be ownable as well. We once again wants to use enumerable sets, so using enumerable set for variable set dot bytes 32 set, and then we'll have all of this immutable variables once again here. But also we will add something like this. So this is going to be address internal immutable I automation registry. This means that we want this raffle to be executed by Chainlink automation. So we want to have multiple rounds of this raffle. And to do that, we can put this this contract on autopilot and execute it using Chainlink automation. So that's why. Please share your Twitter profile. Yeah, I'll do that. It's Andre_dev. This is my Twitter profile. Once again, I'll post the GitHub repo there. Yeah, thank you. There it is. Thank you. Cool. Once again, yeah, we need a number of words. We can reuse it from here. We can delete this comment now. Pretty useless. And also, we need Merkle root. So bytes 32 internal s Merkle root. And again, participants and winners. Where's the static raffle? Yeah, here it is. Dynamic participants, winners. Cool. So I added this address. So this means that we're going to execute this by Chainlink automation, and also a Merkle root, which is essentially we need it for our use case. This was pretty simple. So we want to have a couple of events as well. So raffle started, raffle winner, and raffle ended. We can easily reuse. Thanks for the follow, man. And Oh, yeah, let's add a new event for new participants. So new part and participant is Vice32 hash ticket confirmation number. Okay, so that's it. We can have some errors as well. Error is raffle can be run only once. Yeah, that's not what we want. We want something like this. So if there's an invalid ticket, so we want to set invalid ticket, and it's going to be Vice32 hashed ticket confirmation number. And also we'll have something like this. So already entered. It means that you cannot enter the raffle twice. This is to fight civil resistance problem. Number and yeah, let's do a modifier. Caller is not an automation registry. And let's write modifier. So if only automation registry, you can call this. So if message.sender is not automation registry, please revert with this error. Oh, sorry. Underscore. Okay, so we have something already. So most of the stuff of the logic we reused actually from the previous contract. That's why I kind of rushed through this. Let's create a constructor. So constructor should be pretty much the same at some point, I think. Let's go with this. Let's copy the whole, and then we can delete it a bit. So we need participants. No, we don't need participants because we are going to have Merkle tree instead of that. So we need subscription ID, we need VRF coordinator, key hash, called by guest limit, request confirmation, all of that stuff. We need number of words, obviously. We need address automation registry, and we need Merkle proof, which Merkle root, sorry, which is hash. So VRF coordinator there. So subscription ID, VRF coordinator, key hash, callback guest limits, number of words. What I missed? Yeah. So what I'm missing is automation registry, which is automation registry, and also Merkle root. So as Merkle root is Merkle root. So we're not gonna look through this stuff anymore. Again, it's an anti-pattern. And yeah, this is it. So this is our constructor. I'm gonna stop it just for a second so you can see the changes I made. So I added this two stuff, removed participants array, and also just instance these two variables and remove an array from a constructor. Because again, this is an anti-pattern and solidity. Okay, so now if we want to start the raffle, basically, we are gonna do pretty much the same thing as in the previous one. So let's see the code for that. Yeah, we can grab this one. Yeah, no worries. So this is request random words. We're gonna just rename it to start raffle. And now it's gonna be external, but only automation registry can call. Okay, we're requesting random numbers, key hash, all good, all good. So this is our start raffle function. And fulfill random function, random words gonna be a bit different. So I'm not gonna code it at the moment. Let's do enter raffle first. So now we need to have a logic for participants to enter the raffle. So to do that, we should create some kind of mechanism. So let's put it above. So function enter raffle. So to enter the raffle, you need to provide hash version of your ticket confirmation number. Hashed ticket confirmation number, and also a proof that you're inside the Merkle tree. Okay, so this is maybe too much. I'm gonna stop here. External. Let's first create. The functions for hashing. So this is gonna be function. Let's see. So it can be like this. So get hashed ticket confirmation number, and it's gonna be string memory ticket confirmation number. There's gonna be external pure and gonna returns bytes 32 value. And how to hash everything, just catch 256 AB and code packed ticket confirmation number. That's it. So you need to provide that hash here. You can also hash it client side. We're going to hash it inside our tests, but basically this is the flow. And then to enter the raffle, you need to verify that the proof is indeed correct. So how to do that? So Merkle proof function we imported from OfficeAppLink has verify function. So if the proof is not valid, so how to do this? So proof, we need to pass root, which is Merkle root, and we need to pass hash ticket confirmation number, so the actual value. If this is not valid, revert with invalid ticket. Invalid ticket, and yeah, hash ticket confirmation. Okay, so this is the first check. The second check is if you already entered the raffle, you should not be able to be in the raffle again. So participants contains hash ticket confirmation number, or you're among the winners. So winners array contains hash ticket confirmation number, then revert with already entered, and that's it. So we have two checks, and if everything's okay, then what we want to do now is just to add this hash ticket confirmation number as a participant and emit new event, new participant with hash ticket confirmation number. That's it. So we enter the raffle. We have the ability to start the raffle. We just want to get winners one more time, so we're gonna reuse this function, obviously. We can put it here. And final thing is that we should have fulfill random words, which should be the same actually. So let's quickly check. So we have length, we have participants, we have winners, we have emit. Yeah, so fulfill random words once again is gonna be exactly the same as the one in the static raffle. So what's new? Start raffle, exactly the same. Fulfill random words, exactly the same. Get winners, exactly the same. We add the ability, we add new modifiers, only automation registry can call, and we have the ability to now verify that the hash ticket confirmation number is inside the Merkle root. So we imported this Merkle proof, and our enter raffle function changed a bit. So this is the code for the enter raffle function. Once again, copy. What's my favorite song? My favorite song, I don't know. By the way, from Red Hot Chili Peppers, probably. Thanks for asking that, Pippi. Okay. And one last thing is that we should probably modify our tests a bit. How to do that? Let's see how I can just show you that part, because majority of the test code will be probably the same. We should be able to, yeah, let's do it like this, actually. Okay, let's do it like this. So what I'm going to do now is inside the test folder here, I'm going to add shared folder. And there, generate Merkle tree.js file. And yeah, so we're going to use merkletree.js. So what I need to do now is to do npm install save dev merkletree.js. Install that. My favorite browser. Oh, that's a tough one. Probably Brave. Yeah, I'll go with Brave. Thanks, TP. Thanks for the shout out. Okay, so I installed merkletree.js. It's going to help us to generate Merkle trees in JavaScript. So how to do that? So export async function, generate Merkle tree. So we'll have ticket numbers, which is going to be array of strings. And then, yeah, close this to you can see more. This is going to return promise with Merkle root and Merkle tree. But yeah, let's return that later. Okay, so just like this. Okay, so this is just from the docs from the merkletree.js. So we will have leaves. So leaves is basically ticket numbers. We're gonna map this, and for, is this okay? Cannot find ticket numbers. Maybe there's a typo. Oh, there's no typo. Okay. Oh, there is actually an extra. Okay, cool. We'll have ticket number, and we're gonna hash all of that stuff. So create hash out of the string. So how to do that? This kachak 256 to UTF-8 bytes of ticket number, where all the inputs come from, obviously from this library. It's in the chat. Should be in the chat, actually. Okay, and yeah, I need to import Merkle tree from merkletree.js. Yeah, so const Merkle tree. This is again everything from the docs from merkletree.js website. So it's going to be Merkle tree out of leaves. We do have leaves. We'll use kachak256, and we're going to sort pairs to true. So I selected that the hashing algorithm for this Merkle tree is going to be kachak256, and I just need to create Merkle root, and that's going to be Merkle tree get hex root, and that's it. So this is the root that I want to pass to my constructor. So this is the thing that's going to change, and this is going to be, I want to return Merkle root and Merkle tree. Okay, so that's it. One more thing, sorry. Inside the tests now, so obviously you will pass this Merkle root in a constructor, and then inside the test, you will want to do something like this. So you will have, you will just need to create a proof. So because you need to pass the proof to the, where it is, it's enter raffle. Yeah, inside the dynamic raffle, there's, so we need to pass this proof. So this is the thing that changed as well, how you can create that proof easily. So you will do something like this: const proof equals Merkle tree, one more time, get hex root, no, get hex proof, sorry, root is for root, proof is proof, and you just need to pass hash ticket confirmation number. So let's say you have your const ticket confirmation number, which is something like AAA 123, let's say. You need to have hashed version of that ticket confirmation number. So hashed ticket confirmation number, which will be something like that. We will see, and we'll just pass that hash. So this is the proof. So you need to pass proof here to the enter raffle, and how you can hash ticket confirmation number. Well, the same as here. So once again, Kachuk 256, 2 UTF bytes, and now just ticket confirmation number. And that's it. So this is the only addition. So to the test, you will pass Merkle root generated like this inside your constructor. And then you will, for inside your tests, generate proof like this and paste it to the enter raffle. All of the other logic will be the same. Test should work. I'll post the links to my Twitter profile, and that's it. Do you have any final questions, guys, before we wrap this up? And I have some surprise here while you're no? Cool. So today we created static raffle, which we used, which is like a similar code that we use for Big Mac raffle on SmartCon. So I have a couple of Big Macs here. So basically winners were had a chance and pleasure to eat a Big Mac with Sergey at SmartCon, and the other one, the dynamic raffle, was used for you to go to SmartCon to scan the QR code and basically to enter the raffle. That's it. Thank you, guys. Thank you for being with me all up until the end. I know this is maybe too much to follow along on YouTube. I know that, but I will share all of the source code with you. I hope you will learn something new today. I hope this wasn't a waste of your time. And yeah, continue joining the Chainlink Hackathon workshops, create something awesome during the hackathon, and see you around. Once again, all of the source code will be available at this Twitter profile soon after this workshop ends. I just need to grab some lunch before that. See you guys.